Hi, I'm Kevin Wall. I work on the ESAPI team, and I'm here at AppSec USA in New York City. I wanted to talk about some of the changes that are going to go into ESAPI 2.1, specifically in 2.1.1 version, and these probably will be making their way eventually into the 3.0 stuff when it becomes available. First, just kind of, you can study this slide, but basically I've had about 35 years of experience as a developer and in security. I work now for Wells Fargo as an information security engineer doing secure code reviews. So one of the things is that ESAPI had been stable for almost 2 years without really any revisions. Then someone posted to the ESAPI development users or development list a proof of concept thing that showed that they were able to override the message authenticity code to MAC, and by setting the MAC length and setting it to 0 and erasing the MAC, basically they were allowed to override the authenticity checks that we use to ensure the data integrity of the ciphertext and initialization vector. And the result of that is that potentially can lead to a padding oracle attack, which was one of the reasons why we redid the crypto in 2.0 in the first place. The root cause of the problem was because we left code in for ESAPI 1.4 for backward compatibility, which has since been removed. And we've fixed this particular issue. It was fixed in ESAPI 2.1.0 and released on February 2nd, 2013. So if you are using the ESAPI symmetric encryption at all, or in conjunction, which uses it, if you're using the ESAPI encrypted properties, you definitely should upgrade to ESAPI 2.1. There was another CVE that's related to the same thing. It's more of a precautionary measure. It has to do with basically being able to change other information. It's not something that can directly result in a security bypass right now at this point. It could if somebody was able to get the victim to change their ESAPI properties to, like, say, I want you to put in some other cipher transformation like OFD mode or something. By default, the only non-authenticated cipher modes that ESAPI supports is CBC, cipher block chaining mode. But if somebody could come in and say, oh, you should add OFD, like object feedback mode or something, which operates very similar to the way that CBC works, and that's actually what the proof of concept code used, then it would also be possible potentially for them to bypass the authenticity check. So this is being addressed. This is more of a design thing, a design change, and it's being fixed in ESAPI 2.1.1, which has not been released yet, but partly because it requires a minor redesign of the key derivation and the MAC computation. The code is out there right now. It's not complete again under the branches under KWW-crypto-2.1.1, and it still needs a little bit of minor code changes, and especially I need to write some destructive test cases and ensure backward compatibility with earlier versions of, being able to decrypt stuff from earlier versions of ESAPI before I push it out. But it should be, I'm hoping that it will be done by the end of the year. Again, this CVE, although it's been, and if you look in the NVD, it actually has a rating higher in terms of the CVSS score. In my opinion, this is a less This probably be something really more in the, at best the 3 to 4 range probably. They didn't NIST, well, not, yeah, NIST or CERT CC didn't ask me basically on the ranking of this, so they asked me for no feedback. And anyways, regarding this particular CVE 2013-5960, this sort of explains exactly what I'm attempting to do here. Prior to 2.1.1, the MAC and the encryption keys were derived from a main key, and there was no additional context that was added. So basically, this uses a key derivation function that essentially would take that takes this, looks like this, but in this particular case, context is actually empty in prior to 2.1.1. So context is the empty string. The reason for that was because it turns out that it was very difficult to put a context in there that normally a context is something that like a application developer would specify, and for instance it would be something like, Alice is encrypting something to send to Bob, so you may put like the recipient is Alice and or the recipient is Bob and sender is Alice. We couldn't do that without affecting it for everything, because the way the Java encryptor is implemented is as a singleton. So it would affect every instance, every call of it. So one of the things that my first thing that I have to do is basically remove that singleton in Java encryptor. And then there'll be an additional method to set the context. All right. So the plan is basically that the context is going to be used to take the cipher transformation, the KDF version, converted to an integer, the algorithm name that's used for the pseudo-random function, which by default is HMAC 256, and then take the key size, and all that will be put into the context. And then there'll be an option that you could add additional user-specific context. What that'll do is it'll then use that, and it'll derive a different key for the MAC and for the encryption. And those things basically will be automatic. If you start adding user-specific context, then somebody on the other end who's the recipient will have to set the context explicitly before it's decrypted, right? So that'll all be put into the updated user guide for the ESAPI encryption. So that's basically, in summary, what we're going to do. If you have any further questions, like to discuss it, after the talk tomorrow, we're going to be in one of the suites that will be available for questions. That's all. Thanks. Okay, done. Done.